With the goal of longevity, a major focus is to optimize biomarkers of as many organ systems as possible. With that in mind, resting heart rate and heart rate variability provide information about the heart, but also the nervous system and the adrenal gland, which is what we'll see here. So resting heart rate and heart rate variability are measures that are obviously localized to the heart, but their levels are impacted by the balance between the sympathetic nervous system and the parasympathetic nervous system, more specifically the vagus nerve. Additionally, sympathetic nerve activation of the adrenal gland leads the adrenal gland to produce norepinephrine, which also impacts resting heart rate and heart rate variability. All right, so what's optimal for HRV and resting heart rate? And my optimal range is a high heart rate variability with a low resting heart rate. Data that are at least 70 for women and 75 milliseconds for men, and less than 45 beats per minute for resting heart rate. And if you'd like to see those data, I have a new Patreon tier dedicated specifically to what's optimal for biomarkers, including a recent video on HRV and resting heart rate. Besides HRV and resting heart rate, this also includes 33 other biomarkers, more than 2 hours of video content, 52 published references, and note that these aren't the reference ranges. This is what may be optimal based on how each of these biomarkers changes during aging and their associations with all-cause mortality risk. So if you're interested, check it out. In today's video, we'll take a look at what's my data, as I have almost 2,600 days of data for HRV and resting heart rate. And then taking that a step further, which factors may optimize long-term HRV and resting heart rate. So let's start off with HRV. As we'll see, I've consistently increased it over the past 7 years. And that's what we'll see here. This is my average yearly heart rate variability since I started tracking in August of 2018 through the end of August 2025. And again, that's almost 2,600 days of data. And these data are from Whoop, which I've worn the whole time for that whole 7+ year period. And I'm not here to say that they're the best. I'm not here to promote them. I don't have an affiliate link, but this is only what I've worn over that 7+ year span. On the y-axis, we've got HRV, and that's plotted against years. So when I first started tracking in 2018, average HRV was about 47 milliseconds. And note that I've never been sedentary at any point during this 7-year journey or even before. Then I was able to start increasing HRV over time, up to an average of 56 in 2019, around 58 in 2020. I then had a regression in 2021 at 52, up to 59.3 in 2022, 66, around 66 milliseconds in 2023, and then the data has been getting a bit worse over the past 2 years, with average values of 63 in 2024 and currently in 2025 of 59. As a quick aside, I could say, well, I had this infection or this went wrong. It doesn't matter. The fact is, the best athletes are able to stay on the field and produce at a high level year after year after year, and that's what I expect when it comes to longevity. So for whatever reason, I look at it as a learning experience, whether it's infection or something else that may have limited the data, and the goal is to try to get better year after year, or at worst, maintain HRV and not allow it to suffer its age-related decline. Nonetheless, when starting with the data from 2018, we can see that I've consistently increased HRV over that 7-year span from 47 to 59 milliseconds. And that's important, or potentially important, because HRV declines during aging. So at the worst, I've resisted HRV's age-related decline for at least this 7-year period. But note, again, as I mentioned, that the data has been going in the wrong direction for the past 2 years. And I won't get into the details of why that could be, although I've been detailing my progress in terms of HRV and resting heart rate every day on Patreon for a few years. So if you're interested in that story, the daily story, I'd encourage you to check it out. But note that my data is finally, or seems to be, back on the right track. So I recently moved to Austin about 2 months ago, and average HRV over that 2-month period is currently 64 milliseconds. And there too, there are some hiccups that have knocked me off track, and not intentionally, and things that I'll cover in this video that were unexpected, that should help the remainder of 2025 be potentially even better than 64 milliseconds. So we'll have more on that story in a minute. But what about resting heart rate? How has my resting heart rate changed over the past 7 years? And that's what we'll see here. So on the y-axis now, we've got resting heart rate plotted against years on the x. So here, when I started tracking in 2018, average resting heart rate was 50.9 beats per minute, so around 51. And then together, and again, I think we should collectively look at HRV and resting heart rate together. Some people only talk about their HRV or only talk about their resting heart rate. They are complementary measures that add information for one versus the other. So my collective HRV and resting heart rate in 2018 was 47 for HRV and 51 for resting heart rate. Then in 2019, starting in 2019, I was able to start reducing my resting heart rate to an average of 49 beats per minute, to 48.1 beats per minute in 2020, a further reduction to 47 beats per minute in 2021, down to 45 in 2022, around 43 in 2023, and to my lowest level yet for any year, 42.4 in 2024. And then the data has moved a bit in the wrong direction for 2025 at 43.3 beats per minute. But nonetheless, again, note that I've consistently reduced my resting heart rate starting in 2018 from an average of 51 beats per minute to 43 beats per minute. But note that resting heart rate follows an inverse U shape during aging, such that relatively low resting heart rates are found in youth, they peak around midlife, and then they decline from midlife to around 85 years. So am I just on the downward trend for resting heart rate and on the second half following middle age? So is the resting heart rate reduction, is that an indicator of youth or advanced age? So note that HRV declines during aging. So if my resting heart rate decline was an indicator of an aged phenotype, I'd expect to see a chronically lower heart rate variability. In contrast, over the past 7 years, I've increased HRV while reducing resting heart rate, which suggests that this is good news. In terms of what's optimal though, I do have some room for improvement, at least in terms of HRV. As optimal for men, for HRV, my optimal range is 75 milliseconds, as that's the median value that's found in 20-year-olds. So I've got some work to do to get my current value of 64 milliseconds, our average current value, up to 75, at least 75. All right, so which factors may underlie my improvements or changes to resting heart rate and heart rate variability? So in this video, I'm going to focus on three. These aren't all of the factors, but these are three of the factors that may explain a significant fraction of both HRV and resting heart rate. And the first one is skin temperature, and that might not be the one that everyone was thinking of. The first one is probably exercise, right? Just train a lot and your HRV will be super high and your resting heart rate will be super low. But as we'll see, there's more to that story. So skin temperature is actually a recent discovery, one that I'm most excited about, and probably one that most people aren't thinking about. So how does skin temperature correlate with HRV? And that's what we'll see here. So I have data for skin temp going back to January of 2022 through, again, at the end of August 2025, and it's more than 1,300 days of data. And these data are tracked by WHOOP. So on the y-axis, HRV, and that's plotted against skin temperature in degrees Celsius. In terms of Fahrenheit conversion, my range goes from 32°C or 90°F to 35.5°C and about 96 degrees Fahrenheit. Then we can see that there's a significant inverse correlation between skin temperature with HRV. In other words, when my skin temperature reading is higher, relatively higher, that's significantly correlated with a lower HRV, going in the wrong direction, following its age-related trend. On the other hand, on days when my skin temperature is relatively lower, that's significantly correlated with a higher HRV. All right, what about resting heart rate? So here we can see the opposite trend. A higher skin temperature is significantly correlated in my data over those 1,300 days with a higher resting heart rate. And again, note that resting heart rate increases from youth up until around midlife. So this is would be moving in the wrong direction, at least moving in the wrong direction in correlation with a higher skin temperature. On the other hand, a lower skin temperature would be movement in the right direction, as it would be correlated in my data with a lower resting heart rate. So then this raises the question, which factors impact skin temperature? And there may be many, but one may be one that most people aren't thinking of, and that's mattress type. And I learned this, unfortunately, the hard way. So I mentioned that I moved to Austin about 2 months ago. So I bought an air mattress as what I thought was a temporary fix, as my bed hadn't yet arrived, even though I ordered it a week before moving to Austin. So while on the air mattress, over the 53 nights that I've been in Austin, average HRV and resting heart rate are 64.43. Now, during that time too, average skin temp was 34.2 degrees Celsius. Now, my new bed finally arrived, and it was this model here. And again, I'm not affiliated or sponsored. This is just my story. This is just what I did. I bought what I thought was a bed that was going to be best, or one of the best, for cooling, or it should be good for helping keep me cool at night. This was before I even knew about this correlation with skin temperature. And as you can see in their title, it says most affordable cooling. I mean, that's either clever marketing or maybe it's a real effect. At the time, I wasn't as educated on mattresses and the impact of mattresses on skin temperature as I am now, as I've been forced to do a deep dive into that subject. So when the bed first arrived, obviously I slept on it, and my HRV and resting heart rate looked like I had a workout on the day prior, even though it was a rest day. So then I thought, all right, this is a weird thing. Maybe I need to let the bed degas or off gas. So I put the bed outside for about a week, in and out for about a week. Didn't sleep on it. Brought it back in. HRV resting heart rate, again, looked like after a workout day, despite it being a rest day. So then I put the bed away again, didn't sleep on it, went back to the air mattress, revisited it about a month later, and the same phenotype. I mean, I saw heart rate variabilities and resting heart rate values over those 2 days that I haven't seen except for like infection, which is outrageous that a bed can make that big of an impact on my HRV and resting heart rate. So for the 4 nights that I slept on it over 2 months, being in Austin, average HRV resting heart rate is 50.46, which compared to 64.43 is a big dent. I don't see a dent on HRV and resting heart rate of 50.46, even on workout days, which is when you'd expect to see the biggest impact on these metrics. So again, sleeping on this bed, which in hindsight was a memory foam based bed, which again, I didn't know at the time, but memory foam beds tend to run hotter than either hybrid or inner spring focused bed or constructed beds. So with that in mind, I've purchased a new bed, and I'm still waiting on that. It should arrive next week. I'm gonna let it off gas for about a week, and then I'm gonna have to repeat this cycle of, is the bed allowing for maximal cooling and not helping to raise my skin temperature? So skin temperature on those 4 nights of sleeping on the new bed was higher, 34.8. And when using a 2-sample t-test to compare these 2 groups of data, the 4 nights on the new bed versus the 53 nights on the air bed, they are significantly different. So if you're struggling with HRV and or resting heart rate, your mattress may have something to do with it. And in hindsight, and going back to my HRV resting heart rate story, I bought a memory foam mattress topper in May of 2024. And coincidentally, in looking back in hindsight, that's when my HRV and resting heart rate started to make moves in the wrong direction for the remainder of 2024 and early into 2025. All right, so what other factors impact HRV and resting heart rate? Body weight is another factor that may impact both HRV and resting heart rate. And we'll start off with the data for body weight versus HRV as shown there. And this is where I have the most data, as I have tracked body weight data on all days of HRV and resting heart rate tracking. So almost 2,600 days, going back from August of 2018 to late August of 2025. On the y-axis, we've got HRV, and that's plotted against body weight on the x. And here we can see a significant inverse correlation. In other words, when body weight has been higher, that's significantly correlated with lower HRV. And when body weight has been on the lower side, that's significantly correlated with a lower HRV. Now, my current body weight is about 141 pounds, so that would put me somewhere towards the lower end of this correlation. In other words, towards the higher end of HRV. Now, I could go lower for body weight, but in my experience, going lower than 140 or 141, I'm currently 5'7", that starts to mess with in-workout performance. And I'm not trying to lose strength or muscle mass. The goal is to optimize that while also optimizing HRV and resting heart rate. All right, what's the correlation for body weight with resting heart rate? That's what we'll see here. And now we've got a significant positive correlation, and we can see that that correlation coefficient is 0.74. Anything greater than 0.7 is considered a strong correlation. So in this case, a relatively higher body weight is significantly correlated with a higher resting heart rate, and conversely, a lower body weight is significantly correlated with lower resting heart rates, at least in my data. In terms of my current body weight, you can see that that would put me somewhere there towards the lower end of a resting heart rate closer to around 43, 42. So from both of these data, from both of these correlations, we can see that a lower body weight is significantly correlated with a higher HRV and a lower resting heart rate. All right, so then the most obvious one is physical activity. How might that impact, or what do the correlations show for HRV and resting heart rate? So in terms of physical activity, I'm going to show data for the average daily heart rate. That's a full day average heart rate. So in contrast with steps, you could take 1,000 steps on flat ground or 1,000 steps up a hill. One of those is going to have a higher heart rate as a response, the one going up the hill. So I find that tracking the average daily heart rate is more informative than tracking steps or other measures of physical activity. You know, I could track workouts, but I find that the average daily heart rate incorporates all of that. On the other hand, the average daily heart rate doesn't just include activity or exercise. Emotional stress, periods of extreme emotional stress, whether it's work or relationships, can also increase the average daily heart rate, sympathetic nerve activation. So most of this story is exercise driven, but emotional stress can also drive some of this effect. So in terms of the data, that's what we'll see here. On the y-axis, we've got next day heart rate variability plotted against the previous day average daily heart rate. And for this, I have about 2,000 days of data going back from March of 2020 through August of 2025. In terms of the correlation, we can see that there is a significant inverse correlation. In other words, when the average daily heart rate is higher, that's significantly correlated with a lower next day heart rate variability, which shouldn't be much of a surprise. If we do a hard workout, it's reasonable to expect that HRV should be lower than it was on the prior day. All right, what about the correlation with resting heart rate? So over the same time period, from March of 2020 through August of 2025, now we can see a significant positive correlation. And again, another strong correlation as that correlation coefficient is greater than 0.75. So here too, the higher the average daily heart rate, the worse the next day resting heart rate. And again, there too, it shouldn't be a surprise. Hard workout should probably lead to a worse resting heart rate on the next day. Now, I'm not at all suggesting that we remove workouts in order to improve long-term HRV and resting heart rate. On the other hand, it suggests that balancing active versus less active days is important for optimizing HRV and resting heart rate. So what does that look like? So here's a 1 week plot. Actually, this is the end of August for my average daily heart rate. Now, on one of those days, so starting on the third day, and I'll backtrack to the first 2 days in a minute, but on that third day, I included 15 minutes of HIIT, high intensity interval training, on the bike outside. And then on the next day, I did my standard 60-minute workout. So this is a full body compound movement focused workout. It also includes calisthenics, mobility, flexibility, balance, everything. Everything aimed at full body functional and strength optimization. And then note that on the 2 subsequent days, I purposely titrated the average daily heart rate lower from 56 to 54 and then 52 beats per minute, as in my experience, if I don't allow my average daily heart rate to come down, that won't allow HRV to go back to its relatively high level and resting heart rate to go down to its relatively low level. So I could just train through everything and be chronically overtrained, not just in the gym or in the workouts, but also based on these metrics of stress, cardiovascular and adrenal function, HRV and resting heart rate. So after that second day, HRV and resting heart rate were close to where they usually are or better. So then I included another 60-minute workout. And then after that 60-minute workout, then that takes us into the next 2 days where I would titrate activity lower. So 57 versus say 53, 54 beats per minute. And this is the approach that I've used for a very long time. I let HRV and resting heart rate dictate intensity, duration, and frequency of my workouts with the goal of optimizing not just long-term fitness and health, but also HRV and resting heart rate. All right, so now we can put the story all together by asking the question, what percentage of HRV and resting heart rate can be collectively explained by these 3 variables, skin temp, body weight, and the average daily heart rate? Let's start off with the data for resting heart rate, which is what we'll see here. So this is a multivariate linear regression model where we've got the collective association between those 3 variables, again, skin temp, body weight, and the average daily heart rate against resting heart rate. And collectively, we can see that this is a significant association. These 3 variables are collectively associated with resting heart rate, as the significance F is far below a p-value of less than 0.05. You can see it's 6 times 10 to the negative 279, and this is a very strong association. In terms of the adjusted R squared, this is the proportion of resting heart rate that can be explained by just these 3 variables. It's 0.63 or 63%. In other words, 63% of the variability inherent in resting heart rate can be explained by just these 3 factors. So that's on the one hand. On the other hand, that means that there's 37% that I still haven't yet discovered. And my goal is to have it completely quantified where we've got this down to a science. If you give me, say, 5 variables, maybe I could predict your resting heart rate with 80% or greater accuracy. All right, what about heart rate variability? So same setup, those 3 variables, skin temp, body weight, and the ADHR, average daily heart rate, and their collective association here too is significantly correlated. significantly associated with heart rate variability. In terms of the proportion of variability explained by these three factors for HRV, it's lower, but still pretty good at 0.36 or 36%. So together, these three factors explain 63% of resting heart rate and 36% of the variability in HRV. All right, that's all for now. If you're interested in more about my attempts to biohack aging, check us out on Patreon, where I offer blood test consults that also include optimizing HRV and resting heart rate. I also post at least twice a day in 4 other Patreon tiers. We've also got a whole bunch of discount and affiliate links that you can use to test yourself that help support the channel, including ultralabtest.com, which is where I get the majority of my blood tests done, the clearly filtered water filter, which I use every day, at-home metabolomics, I've got 19 tests so far for that, oral microbiome composition, almost 19 tests for that, working my way up to that too, NAD testing with Infinity, epigenetic testing with True Diagnostic, Cyclox Health, which has the best epigenetic clock amongst epigenetic clocks, GrimAge, green tea, which I drink every day, diet tracking with Chronometer, or if you'd like to support the channel, you can do that with the website Buy Me a Coffee. We've also got merch, including Data is my North Star, Figuring Stuff Out is my drug, which is what I've got on here, and the ConquerAging or Die Trying logo as shown there. Link in the video's description. Thanks for watching. I hope that you enjoyed the video. Have a great day.